All right, let's talk about something you've probably never seen, but that powers, well, pretty much everything. We're diving deep into these hidden electrical superhighways and the incredible machines that build them.
So, think about it. Our entire world runs on electricity, right? We're talking data centers, electric cars, renewable energy, the list goes on. But have you ever stopped to wonder how all that massive, raw power gets managed safely once it's inside the machine? How does it get from point A to point B without everything, melting? So, here's how we're going to tackle this. First, we're going to meet the unsung hero of the electrical world. Then, we'll get into why good enough is a recipe for disaster in this game. After that, we'll check out the evolution of the machines that do this work, figure out how you pick the right one for the job, and finally, we'll see why this is all so critical for our future. All right, first up, let's pull back the curtain on this one component. This thing you've definitely never heard of, but you 100% rely on every single day. And here it is. It's called a bus bar. The best way to think of it, it's literally an electrical superhighway. Instead of a chaotic mess of countless wires, you have this solid, beefy strip of metal, usually copper, that cleanly and super efficiently distributes massive amounts of power inside things like switchgear and panel boards, all that critical equipment. Okay, so now we know what a bus bar is. But the next question is, how do you make one? Because when you're playing with this much power, this isn't just a case of bending some metal. No way. This is an art form where precision is the name of the game. And here's why that precision is so important. We are talking about components that regularly, and I mean continuously, handle over 1,000 amps of current. Now, to put that in perspective, your main circuit breaker at home is probably, 100, maybe 200 amps? This is a completely different universe of power. So what happens when you mess this up? Well, the stakes are incredibly high. A hole that's just a tiny bit off? Your connection isn't safe. See those tiny metal shavings called burrs? If you leave those behind, you're basically creating a launch pad for a dangerous electrical arc. And if the bend angles aren't perfect, it just won't fit, which means huge labor costs and delays. At the end of the day, you're looking at a real risk of catastrophic equipment failure, or even fire. And get this, to punch a single standard bolt hole into one of these copper bars takes 40 tons of force. 40 tons. To help you picture that, it's literally like having an entire herd of elephants stamped down on one tiny spot. Now, taming that kind of force, that takes some serious machinery. Which, of course, brings us to the machines themselves. Let's take a look at how the technology has evolved. These amazing machines that are designed to tame metal with just mind-blowing accuracy. And you can see a really clear progression here. It all started with manual machines, where everything depended on the skill of the operator. Then we got these clever 3-in-1 machines that combined cutting, punching, and bending all into one unit. And that brings us to today, with fully automated CNC processing centers that give you the absolute maximum in precision and speed. And when I say precision, I mean it. The accuracy of these modern CNC machines is just wild. We're talking a positioning accuracy of plus or minus zero point 0.02 millimeters. You know how thin that is? That is thinner than a single strand of human hair. Incredible. This chart really spells out just how big of a leap that is. Just look at the positioning accuracy. You go from 0.5 millimeter on a standard machine down to that hair-thin 0.02 on a CNC. And the production rate? It doesn't just double, it quadruples or even more. But check this out, tool changing time. It goes from 5 or 10 minutes down to just 3 to 5 seconds. That right there is the magic of automation. But, of course, all that incredible tech, it doesn't come cheap. So for this next part, let's get practical and talk about the real-world business decisions that have to be made, balancing what you need with what you can afford. So yeah, the big question is, what's the price tag for this kind of precision? What does the investment really look like? Well, this table breaks it down really nicely. Look, if you're a small shop, maybe making fewer than 200 of these a month, an economic 3-in-1 machine makes total sense. It gets the job done. But as your volume starts to creep up into the hundreds or even thousands per month, you start climbing that ladder. And that's when you get to the entry-level CNC machines, where yeah, the investment is a big jump, but the payoff in pure speed and output is just massive. And this is such a critical point. Bigger and more expensive is not always better. This quote from a total cost analysis says it all. For a small panel shop doing, say, 300 bus bars a month, the crazy price difference for a high-end CNC machine would take 20 years to pay for itself in labor savings alone. So sometimes, the simpler, more economical machine is actually the smartest financial choice you can make.
Okay, let's bring this all home. Why have we been talking about this? Why does any of this matter? Because this humble, hidden component is, and I'm not exaggerating, the backbone of our entire technological future. I mean, just look at the money involved. The market for these things is projected to be nearly $19 billion by 2027. That is a huge number, and that growth is being driven by all the tech we're counting on for the future.
And this is where it gets personal. This is why it matters to you. The reliability of the cloud and all our data centers, that depends on bus bars. The efficiency of solar and wind farms, bus bars again. The safety and speed of the charger for your electric car, you guessed it. The stability of the automated factories that build everything we use, all of it relies on these perfectly made bus bars to handle immense power safely and reliably. So the next time you charge your car or tap on your screen or just flip a light switch, maybe you'll think about that hidden superhighway. That shiny strip of copper, forged with the force of elephants and the precision of a human hair, working silently, perfectly, behind the scenes, just to make your world work.